Hi, welcome to online tutorial series on Arduino and IoT. This is lesson 16 and in this lesson we will learn how to interface ultrasonic sensor to Arduino. We also provide online training, help in technical assignments. We also do freelance projects based on machine learning, data science, Matlab, embedded system, Python, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org. You can also mail us at jcbrolabs@gmail.com. Okay, so this ultrasonic sensor are generally used for distance measurement and generally are also known as a sonar as well. They also work on the principle of sonar. So what exactly it do? It transmits some sound waves of high frequency sound waves, because ultrasonic waves are those, and then it receives, and based on that it estimates the distance of the object. So this is a sensor which is used for this ultrasonic distance measurement, right? And it has 4 pins: VCC, trigger, echo and ground. So VCC is connected to plus 5 volt and ground is connected to ground. And now we will discuss about the two remaining function of remaining 2 pins, trigger and echo. So first let's talk about trigger pin. So trigger pin is used to trigger this sensor so that it start working, right? So trigger, in order to start this sensor, we have to send a high pulse at trigger pin, right? And the duration of this pulse, that should be of 10 microsecond. That means first of all we need to send a 10 microsecond pulse to this trigger pin, and this trigger pin will activate this ultrasonic sensor and transmitter will start transmitting. After this trigger pulse ends, this ultrasonic sensor will send these ultrasonic burst, we can say a wave burst, or these 8 cycles of this wave, 8 cycles of ultrasonic frequency, right? And then as soon as this ends at the echo pin, the voltage at echo pin or the logic level echo pin goes high as soon as it ends with sending the pulses, and it remains high till it receives the reflected wave or till the time outs. So we can say this is the echo pin. So in order to understand better, let's say we have transmitter and receiver. So this is the transmitter and receiver. So as soon as we got trigger, that means we apply this 10 microsecond pulse at trigger pin, this transmitter will transmit the waves, right? And this is our object. So our waves will got reflected back from this object and reach to the receiver. So as soon as it ends with the sending these pulses, this echo pin goes high and it goes low as soon as our receiver receives some reflected ultrasonic waves, right? So in that sense, this time period is a function of a distance of the object, and if we can calculate this time, then we can estimate the distance of the object from this ultrasonic sensor. So let's say this has a total time of t, right? So the distance will be, we can say the object distance will be, because distance is a very simple formula. It is time into velocity, right? And right now our waves is traveling 2 times of this distance, because one for going forward and one for coming backward. So a distance accurate measurement will be t into velocity divided by 2, right? So this is the simplest formula and we will implement it. Now about the velocity, right? If the velocity is of the sound waves are 343 meter per second. So, and generally this time is in microseconds, so we want to represent it in microseconds only. And further, it is in meter per second, so we can represent it in centimeter per microsecond. So centimeter per microsecond will be 34300. It becomes centimeter, and it becomes a microsecond. So right now this velocity is represented in centimeter per microsecond. So overall this distance, we can simply write this distance equals to T into it will become 0.0343 divided by 2, and this will be a formula to measure the distance in centimeters, right? Provided here this T, this measured T of the pulse duration is in microseconds one. Okay, so this is how we can measure the distance of the object using this ultrasonic sensor. Now we will learn how to connect these sensors to this Arduino, right? So here we have Arduino board, and then let's in this Arduino board, this is our ultrasonic sensor, right? So it has 4 pins. Right, so it is eco, we can say eco, and this is eco, this is ground, this is trigger, and this is VCC. Okay, so this eco pin is connected to pin number 9 of this Arduino, and this trigger is connected to pin number 8 of the Arduino, and then this is connected to +5, and ground is connected to. So in order to display the result, we also have connected a LCD to it, right? So LCD, RS and enable pin, most famous one which will be needed. So this RS is connected to pin number 6 of the Arduino, and enable is connected to pin number 7, and remaining 4 pins we have permanently made this read write pin to the ground, one more pin. So these 4 pins are connected to pin number 2, 3, 4 and 5 of the Arduino, right? So it is DB4, 5, 6 and 7. So these are Arduino pins. So this is how we have created a hardware setup. Now let's have a look on the hardware setup, how we have created it and how we have arranged it. So let's have a look. Hi, so this is our hardware setup for interfacing this ultrasonic sensor to Arduino. Here we have ultrasonic sensor. It has 4 pins: VCC, eco, trigger and ground. Eco pin is connected to pin number 9 of this Arduino, and trigger is connected to pin number 8 of the Arduino. In order to provide power supply to all other circuit components, we have taken VCC from this Arduino to that breadboard, and from that breadboard we are providing supply to this ultrasonic sensor and to LCD. Now we also have LCD to display the distance measured in centimeter. Now pin number RS of this LCD is connected to pin number 6, and enable pin of this LCD is connected to pin number 7 of this Arduino, and 4 data pins, that is pin number DB4 to DB7 of this LCD, are connected to pin number 2, 3, 4 and 5 respectively. So this is very brief about this hardware setup. Here we have a scale on which we will be putting an obstacle in front of this ultrasonic sensor, and we will be displaying the distance on this LCD. So now let's have a look how to program in order to interface this ultrasonic sensor to Arduino. Okay, so now you have seen your hardware. Now it's time to start writing a program for measuring the distance and then displaying the distance on serial monitor as well as on LCD. Okay, so let's start. Okay, let's open the hardware setup as well. So here you will be seeing the hardware. Okay, so minimize it. Let's open Arduino IDE. Okay. Let's create a new file. Okay, and let's first save this file as uh, lesson 16 and ultrasonic. Okay, so let's define the pin. Okay, so integer, let's define a pin number so that we can make it to the constant. So int trigger pin is connected to pin number 8, and echo, it is connected to pin number 9, right? And then let's define two variables because we will be calculating distance and time. Okay, so long, we can make it float. Float could be long float of, let's say, time. Not time is an internal variable, so let's say duration, we can write it like duration, and let's initialize it, initial value is 0.0, and then long distance, long float distance equals to again 0.0. Okay, so let's first without float, and let's see what happens. Okay. Right, so let's initialize our various aspects. So initialization means simple, because we right now first will try to send the data on a serial monitor only. SCRI serial dot begin 9600. Okay, so now we will send, we will give a trigger pin 10 microsecond pulse at trigger pin. Okay, so let's start send to the high. Okay, so digital write, which one is okay, we need to initialize these pins as well. So pin mode trig comma put, and pin mode echo comma input. Okay, so now digital write trig comma high. Now we have to wait for delay in microsecond. So I think its name should be delay microseconds. So we will provide a delay microsecond of 10 microsecond delay, and then we will make it to 0. So it will trigger the sensor, trigger to low. Now as soon as it's low, this ultrasonic sensor will send 8 pulses, right? So now we need to calculate the time. So there is a function built in Arduino pulse in. So this function, if we provide add pulse in as high, so it will check when the pin goes high, it starts the timer and calculate the time duration remain high, and it stops it as soon as pin goes low, and it gives it returns the value in microseconds. Okay, so we will calculate for that for duration. So duration equals to pulse in at echo pin, because we are measuring at echo pin and the state is high. So as I mentioned, how it works, So as soon as, let's say, so as soon as it goes low to high, it starts timer, and as it stops it as soon as it goes high to low, and then it returns total duration of the pulse as the subtracted one, T2 minus T1. So this is how we can measure this time pulse. Okay, and then a distance is a simple formula. So dist, I think this was a variable, yes. So it will be a duration into 0.0343 divided by 2. Now let's send the data to serial monitor. So serial.println can write like we can simply send this to it, and then okay, we can also serial.println as distance. Okay, and then we will provide a delay of, let's say, 500 milliseconds. After each 500 millisecond we want to display the data. So let's increase the time. So now let's compile it and check for the errors and download the program on this Arduino. Okay, Arduino is not connected. Sorry. Let's connect the Arduino board. Yep. So it has uploaded. Okay, I hope you can see on this camera as well. Yep. Okay, so let's see the serial monitor, what we are getting. Okay, so right now it is nearly 10 centimeter, you can see. We are getting exactly 10. Now reduce the distance to 9. Okay, so what is happening, because it is an integer type variable, we are recording this in an integer type variable. Right now it is long, so it is not giving us values in decimal. So it's specific only 9 centimeter, 8 centimeter, 10 centimeter, 7 centimeter, 6, 4, 3 and 3. Let's say whether it can go to 2. No, so it can go up to 3 only, and then it can go up to 17 centimeters. So it is measuring the distance accurately in terms of centimeter, right? So now let's change that a little bit, make it in float, and check how accurately it is giving our results. So long float and long float as well, right? So let's upload the data again. Long invalid. Oh, why? Yeah, it should be float only. Save it and let's upload the data. Then uploading, and let's see. Okay, serial monitor. Yeah. So it is 8.6, 8.4, and a little variation is there. Similarly, if we make it, let's say, to 9.5, yeah, it is giving precise, nearly precise results, and 11.42. Okay, now let's do some experiment with it. If I create it a tilted surface, it is on the same plot, but now it is giving us different readings, right? And then if I make it more tilted, yeah, it starts giving 148 centimeter, which is not. So let's do something. If I put an obstacle right now, so let's see whether you are able to see it or not. Yeah, so what we have done, we have put an object here. So what is happening? Waves are getting this one, getting reflected here and then coming here. So path is now longer than the usual, so it seems like distance is longer as well. So you must be taken care, right, how to measure the distance. So this ultrasonic sensor may not be able to give you precise results if it is at a tilted position. Okay. So now let's do certain changes in it, and let's interface the LCD as well so that we can display the data on LCD. So let's make it to this one only. So in order to add the LCD, we need to add the header file hash include liquid crystal .h and then liquid crystal LCD and the pin number RS enable, right, and then we need to write LCD dot again because we want to write on 16 cross 2, right, and LCD dot clear. So we'll type here LCD dot clear and then LCD dot set cursor 0, 0 and we'll type LCD dot print distance and then we'll set the cursor to other position LCD dot set cursor column number 1 2 3 4 5 6 7 8 column number 9 comma row number 0 and then LCD dot print of distance. Okay, so now let's upload the data. Let's see what values we are getting. Yeah, so now you are getting on it. Now let's see how our final project looks like with the final LCD and all those interfacing with the ultrasonic sensor interfacing. Okay, so let's have a look. Hi, so we have uploaded the program on this Arduino. Right, this is ultrasonic sensor and we have placed a little above than this surface so that our reflection doesn't come from this surface. So this is done in order to reduce the measurement error, right? And here this LCD, on LCD we are showing the distance, right? Okay, now we have this object, right? Let's move this objects to some other, let's say to 6 centimeter. Yep. So it is giving the values around 6 centimeter. Now the problem with this ultrasonic sensor is like your reflective surface should be perpendicular to the surface in order to get the exact readings. Okay, so let's put it around here. Yeah, we are getting 6.5, so 6 will be around here. Yep. And let's increase it to further 5 centimeter. Yeah, to 3 centimeter. So it is measuring a good distance around 4 centimeter. Okay, let's try to increase the distance to 10 centimeter. Yes, and let's change it to 12. Yes. Okay, so it is working fine as long as this surface is perpendicular to this ultrasonic sensor. Now let's see what happens if I tilt the surface. So you see the measurement got changed, measurement reading got changed due to the tiltation. This is, let's do it. Yep. Now it is increasing the value. Now if I get reflected here some values, let's say a little more tilt. Okay, and if I put a sensor here, then it is showing some real values, because what is happening here, waves are going this direction and then reflecting back and then receiving by this receiver, so the distance has increased. If I remove it, you will get some larger values, because right now the reflected waves are coming from some other reflections. So this is the things which needs to be taken care of while designing an instrument based on this ultrasonic sensor. So our measurement should be such that like the reflected surface must be as perpendicular as possible to the ultrasonic sensor. Okay, so we are getting the correct values of 12 centimeter around it. Okay, so I hope you understand it, how to interface this ultrasonic sensor and how to get the readings of this ultrasonic sensor. So now let's come back to the theory part of it. Okay, so you have seen how our project works fine and how it looks like after completing it. So I hope you understand a lot, like how to interface an ultrasonic sensor and what are the shortcomings of measuring a distance using ultrasonic sensor, and how what should be taken care of while designing any hardware based on ultrasonic sensor. Okay, so please keep all those points in mind. Now finally, we also provide online training, help in technical assignments. We also do freelance project based on machine learning, data science, embedded system, Matlab, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. So that's it for this video. Thank you.